Okay, we've moved to question 2. Now, if you look at a swimming pool, now that's a very favorite question. You know, you got a shallow end and a deep end of the pool. Now, at Long Beach swimming pool of length 50 meters and width 20 meters, its depth is a gradual slope from 1 meter at the shallow end to 2.5 meters at a deep end. The pool is filled with water. Calculate the volume of water and the total surface area of the pool in contact with water. Now let's do these two parts first before we move on to the next part about cleaning up the pool. Now you look at the pool, 50, 20, and you got 2.5. This is the deep end and that's the shallow end. Now what shape is this figure? Is it a prism or is it a pyramid? If you look at this part is the same shape as this end. And as long as you have the same shape from end to end, that becomes a prism. Alright, they're both the same shape. You can see that it is a trapezium, just like here is a trapezium. Alright, from this wall to that wall. Now in a trapezium, we look at parallel sides. So the volume of the water is actually the area of the cross section times the distance between the two sides that are congruent, equal, identical. So that distance is 20, like here. This is also 20 meters. So we look at this trapezium, deep end 2.5, shallow end 1 meters, and what will be the volume? The volume of a prism is always the area of the cross section times the height. And in this case, the volume will be the area of the base, B1 plus B2 divided by 2 times the height of this trapezium. Now the parallel sides here, this is B1, B2, and the height here is this length, this is the height between the two parallel sides. Multiplied by the width here, the distance from here to this end, multiplied by that h. That will give us the volume. So what is the parallel sides? You got 1 plus 2.5 divide by 2 multiplied by the height from here to here, 50. This gives us the area of the cross section, and that cross section is a trapezium. Multiplied by this height, which is 20. I would like to work out this first. You can see that this is 1 plus 2.5 is 3.5. You cancel this 2, you get 25. So let's put it as 3.5. 3.5 times 25. We've got this beautiful answer, 87.5. This is actually your trapezium. Alright, multiply by 20. So you multiply that by 20, you've got the volume of the water is 1750 meter cube. Take note of the units of measurement. That's the volume of the water in the pool. Now the next part is they want to find total surface area in contact with water. Now it will be the total surface area will be made up of all the sides that's in contact with the water. Now it will be this trapezium plus this trapezium. So the total surface area, I shall put it as TSA, is made up of the area of 2 trapeziums. Alright, the area, please put down as area. I don't like the way I'm writing my answer right here, but I hope you could write it clearly. Alright, the total surface area will be the area of 2 trapeziums, right? 1, 2. And then you've got these 2 rectangles here, the big rectangle and this rectangle, plus the shallow this rectangle that's going right down from this end to this end, going down. So you can see the area of 1, 2, and 3 rectangles. Area of 3 rectangles. Now the worry here is, how do we find? Okay, the trapeziums, no problem. We've got the answer of trapezium, 87.5 times 2. That's one part. Area of the 2 trapeziums. One rectangle here is 1 times 20. Yeah. The second rectangle is 2.5 times 20. And we've got to find now the third, the one that is sloping from the shallow end going right down to the bottom, all right, the deep end. We look at this rectangle at the bottom, this rectangle. Now we need to know what is this length and how do you work out this length. So well, what we do is we say, hey, cut this into the rectangle here. Look at it here, cut this off. This will be 1 meter. This will be 1.5. And this length is 50. So by Pythagoras theorem, we could work this out. Alright? So it's 50 squared plus 1.5 squared square root. So this will be 50 squared plus 1.5 squared, and you put a square root. What does that work it out to? Alright? Okay, let's do it steadily. 50 squared plus 1.5 squared. What am I writing there? I got to remove, delete. Alright? 1.5 squared. Get your answer and then you find the square root of it. Alright? Okay. Read again. I find square root Alright, we get the length to be 50.002. Alright, so that's very small. It's almost 50, it looks like, but let me write it down. 50.02. That's the length here. So it's going to be the length, the area of this slope will be here, which is 20, right, times this length, which is 50.02. Working all this out, we would get the surface area. Now what is 87.5 times 2? Look at that. You've got 2 times 5 is 10. Carry up 14, 15. Carry up 1, 16, 175. Plus 20. And here you've got 2.5 times 20. Alright, 2.5 times 2 is 10, is 5, 50. Alright, just check it out if you're not very sure. 2.5 times 20. See it. Okay, you get 50. Now 20 times 20 times 50.02. What do you get? You've got 1,000.4. Wow. So add the total area up. You've got 1,000, 100. You add them up all together, all right? Plus 175 plus 70. All right, add them up and you get this answer. You get a 1,245.2 cm squared. All right, I've always not encouraged using calculator. I just wanted to just put a bit of speed and be very sure, counter check. Even if I did without calculator, I would still reassure to make sure that you don't want to take the risk. So you use the calculator to check against your working. Alright, but if you have time, try not to use the calculator if you can manage without certain situation. So this is the total surface area. You have this plus that, okay? I like to say again, the trapeziums plus this rectangle, and the slope rectangle. The slope rectangle is where it becomes not very easy. This is what I meant the slope rectangle. And that slope rectangle takes this length, which is 20, times this slope length, which is 50.02. But how do we get that? We used a Pythagoras theorem. Well, this is 1, 1. So this will be 1.5. This is 90 degrees. This is 50. So you work that very close to 50, 50.02. Now this is the area. The area is in meters squared. Alright, all these measurements are given in meters. Now once we've done that, let's move on. Calculate during a cleanup. Okay, water is drained out by 2 pipes of different radius in 6 hours they take. The larger pipe took 12 hours less than the smaller pipe if done alone. Taking the time taken by the smaller pipe to drain the pool alone as x hours. So write an equation that it reduces to this x squared minus 24x plus 72, and you have to solve and comment on the solution. Now, if the smaller pipe, alright, this is B and let's look at C. If the smaller pipe takes x hours, how long does the larger pipe take? The larger pipe will take x plus 12 or minus 12. Please tell me. 12 hours less. So it's x minus 12 hours. That's the time taken by the larger pipe. This is x. Together, when they're draining this whole swimming pool, it will take 6 hours. Now we look at the sum again, C here. Alright, this is A, B, and C. Now in 1 hour, the smaller pipe will take 1 over x. Alright, 1 over x in 1 hour. How much of the pool is drained out? If they take x hours to drain the pool, in 1 hour, 1 over x of the fraction of the pool that be drained by the small pipe. That's done by the small pipe. The large pipe in 1 hour, if it takes x minus 12 hours to drain the whole pool, alright, by itself, in 1 hour, the fraction of it will be 1 over x minus 12. Now, these two, if they are on, the small pipe and the large pipe is on, together they will be drained. Alright, the whole tank will be drained in 6 hours. So in 1 hour, 1/6 of the swimming pool will be drained. This is the most important part. Now, for example, the small pipe takes 20 hours to drain it. Example, if x is 20, in 1 hour, what fraction of the pool is drained? 1 over 20th. In 2 hours, 2 over 20th. In 10 hours, 10 over 20, half the pool. And in 20 hours, pool is totally drained. Alright, the whole pool, 20 over 20, that means 1 whole of the pool is drained. So just like that, now that we've introduced x, in 1 hour is 1 over x. Similarly, the large pipe, if it takes 4 hours to, it should take more than 6. If it takes 8 hours to drain it, now in 1 hour, it will drain 1/8. In 2 hours, 2/8. 8 hours, 1 whole. So we look at that now in terms of x. 1 over x minus 12. That's the that's the fraction of the pool that's drained. So together, in 1 hour, the 2 pipes would drain 1/6 of the pool. Now we find the LCM here, x minus 12. Alright, it's a simple algebra. X is gone. You get x minus 12 times 1. Here x minus 12 is gone. X times 1 is x. What we've got here is 2x minus 12, right? And here's the x squared minus 12x. Bring it up, the 6 goes there. Times 6, and here is x squared minus 12x. Now bring everything. This is a 12x minus a 72. You got an x squared minus 12x. My dear, bring this over. You get a 0. You've got an x squared Minus 12x is a minus 24x plus a 72. This is the solution. Alright? Alright, now we want to interpret this, we want to find the solution in D. If we could factorize it, well and good. If we cannot, then we use the generic formula. Now if you look at 72, 72 is made of 1 times 72, which is not possible combination, 2 times 36, the difference and the sum does not give us 24. If it's 3, we divide by 3, 3 times 24, alright, and does it give us? No. So it looks like we may not be in a situation. If we divide by 4, let's see whether we get that. If we divide by 4, we get 1, 8, 18 and 4, 22. If we divide by 6, is 12. So the best method would be to use the generic formula. So let's use the generic formula. What's the generic formula, by the way? X equals to, let's take the space. X equals to minus b plus or minus b squared minus 4ac over 2a. Put in the formula and the answer and you would get it. Alright, can I give you a minute to work on that? Don't look at the board and you get the answer as fast as you can. Alright, now we worked it out. Alright, you're going to put in the values. You're going to put your b squared. Do y'all do that? Put it in. Definitely you can see that it cannot be factorized. And your x will be 20.485, which is about 20.5 3SF. Or x is equals to 3.51. The very fact they tell you to comment on the solution, alright, comment on the solution, tells us that 1 is a reject. X is 20.5, yes, alright, it takes x is equals to 20.5. And your other x, which is equal to 3.51, right, 20.5, 3.51, you have to reject it because x hours, when they tell us that 2 pipes take 6 hours. So how can you take less? X is the number of hours that's taken to drain the pool. And you take the 2 large pipes, large and the small, 6 hours. This is absurd. So this will be x. It takes the smaller pipe, will take 20.5 hours to drain, while the larger pipe will take 20 minus 12. That's about 8.5 hours. Alright? So okay, this is a good sum to apply when we applying algebra and we are applying, shall I say, the formulas. Secondary 2 students, you should be able to do it. Sec 3, Sec 4, you should sail through. But one thing very clear, got to take note how you find like area, volume. Take note of it. Swimming pool is a very popular sum for exams. Now you find the volume, look at the trapezium. Trapezium. And that's your cross-section area. The distance between them will be the height. Fit in, find the area of the trapezium times the height. The distance between it, when we talk about height, the distance between the two cross-section area, we cut, the same. So that's what we call for pyramid. This is, prism. When you cut, it's the same in a prism. Unlike pyramid, you cut, what do you get? 1 dot. Alright, it comes to a point, like a cone. Alright, whereas prism, you get the same shape, you get a loop. If I did take this as a cross section, I will be getting something much bigger that cannot work. And I even cannot take the slope. So look for your cross section area. Very important to distinguish it. So you look at a cross section and the distance between the cross section, that's your height. You've got the volume. For surface area, all that in contact, 2 trapeziums plus the 3 rectangles. But the rectangle is just that we didn't have this slope length, this times this height. We got to work out using Pythagoras theorem. Once we've got the total surface area, the volume done, now the next sum, alright, a very simple understanding, 1 hour. how much do you fill up? 1 hour, large pipe, how much do you fill up? Total 1 hour, 1/6. All right, and then you simplify, solve it. You've got your answer. Comment on the answer. The smaller pipe will take 20.5, closer, round off to 3SF, 20.5 hours. And well, you have to reject it as both pipes will take 6 hours. All right, or you feel charged, all right? As we move on, volume surface area is a must question. You have to answer it and it fetches very good marks if you wish to score in your paper. And be extra cautious. I tend to be a bit so you be extra cautious and look at it. Like if the measurements are in cm, then it's cm cube for volume or cm squared. Measurements are in meters, then the volume is in meter cube or area meter squared. Alright, we will move on to the next few 2 more sums or 3 more sums as we go on. Till then, stay strong and have yourself a nice drink, relax and move on. Alright, cheers!